matter and how they relate to hazardous materials. An uncontrolled hazmat release from a container can create many problems. What we need to look for is the material's physical and chemical properties. And that's going to tell us how it's going to affect, or how that will affect how it behaves. We're going to determine the harm it causes, the influence that affects it, what's it going to do to people, other living organisms, other chemicals, and the environment. You know, that's one of the problems right now. They're making so many chemicals. I forget the last number there was of chemicals, but some of them they don't even know how they react to each other yet. So that makes it even tougher for us in our field. So just remember that other chemicals react with them. It's also going to influence how the container will behave if it's damaged or ruptured. It's already there. We got to remember that material is found in 3 states. Okay, solid, liquids, and gases. And the hazmat incident, try to identify the material's physical state as early as possible. Okay? Because that'll make it a lot easier in determining what we have to do. Just got to remember that the state the matter's in can affect the way the material behaves. If we have liquids, they can pool, stream, flow downhill. They get in, they can either sink or float on water, may release vapors. If we got a gas, it's indefinite shape, expands rapidly. Some of them can displace the oxygen. They can rise or sink in air. Solids, they can react, will stay in place. The only time they don't stay in place is if we have a wind or something that's going to move them. Tiny particles are still going to be there, suspended in air. And sometimes the solids can cause entrapment. In the ERG, we talked about already that they have initial isolation distances, and for most of these, if it's a solid, it's going to be 75 feet. A liquid's going to be 150 feet, and gases are going to be 330 feet. One thing to remember: the solids are the least mobile, and the gases have the greatest mobility. Liquids may be mobile, depending on the property of the substance. Substance state may change if the temperature changes. Here's a good example: a propane cylinder gets heated up. Okay, it takes that liquid propane and does what to it when it heats?
Turns it into a gas.
Turns into a gas. So now we have the part of the tank that doesn't have any liquid in it is filling up with gases and expanding. So we put in what? The cylinders come with a what in them?
PRV.
Yeah.
Relief valve.
Yeah, pressure relief valve. Okay, so that's to take some of the pressure out. And I forgot that picture I was going to bring into you guys. I have a picture at home of one of these tanks that has ruptured. We went out to a fire, a grass fire, and it caught a shed on fire. They had 3 of them in it. They really go. So, don't just think you have to have the huge tank to get a fire. You can happen with the little ones.
I was at a campground in Memphis and they let any of the campers go up and refill their propane tanks. Like you didn't have to have somebody from the campground do it.
Wow.
Yeah, you just swiped your debit card or credit card and there's a couple of them laying there that they overfilled.
That would be a bad deal.
Yeah, it was, I always went during the day, but it was surprising that they let them do it.
Okay, we're gonna talk a little bit about gases here. Are potentially the most dangerous for emergency responders. Many of the hazmat related injuries are due to the inhalation of the vapors or the gases. Some have odor, such as chlorine. Some may be colorless, odorless, tasteless, carbon monoxide. Then we have some that could be a combination. Toxic, such as phosgene. We talked a little bit Thursday what phosgene was. Do you remember what it was? Where we get it at?
Burning
Say it again.
the burning of chloride gas, or,
You're close. Freon. And where do we have Freon?
Refrigeration.
Refrigerations, freezers, air conditioners. So we have it at regular structure fires. Okay? What it does, it gets in your lungs and destroys everything and you actually suffocate. Okay? We also have some corrosive stuff such as ammonia, flammable, methane, and natural gas, stuff like that. Some of them could be extremely cold. Gases have an undefined shape or volume. They will assume whatever they're put into, whatever shape. As long as gases keep expanding, if they're uncontained, they can move throughout a building to another building. They can go through access shafts, into the soil, into the street. We had a call the other day for a gas leak, and it was actually the frost had pushed up against a T across the street, and it was following the gas line over to the house. Okay? So it does go through the ground. You gotta remember, once it comes out, then the wind can get a hold of it and take it wherever. We were sitting right there and all of a sudden we could smell it and then we couldn't smell it. Then we smelled it and then we said, yeah, we might be too close, so we moved trucks. It's alright, the cop car was sitting right on top of it, running. So, gases are the most difficult, if not impossible to contain. Sometimes we just have to let it do what it has to do. Compressed gases, liquefied gases expand rapidly when released. They have a potential to threaten large areas. If a gas is invisible or has little or no odor, it may be impossible to detect it without your gas meters. This just shows that we could take like a 1 or 2 ton quantity of chlorine or anhydrous and release it in an open area, and it expands 360 degrees. Okay? And that's before the wind does something with it. So we're gonna have that 360, then we're gonna have the wind that's gonna take it one way or the other, so. Just remember, when we start putting out our zones, we gotta allow for the wind. Make sure though, that you remember that those expanding gases, they can displace oxygen. Okay, like we had the Freon fill the basement up of a store downtown, and we had to get down there and get that out without any basement windows. We actually got a fan that actually blew down in there and then forced it back up out the top. Because it was displacing the oxygen down there, so they couldn't go down there to fix it. So just remember that situation. We got some gases here, present multiple hazards. Whatever this load is, it has class 8 and class 6 in it. If we have an incident with this, something like this, and it's harder to mitigate, affects larger areas. Liquids usually are visible, even if you can't smell them. They're usually, you can see the liquids. That's how you detect their presence, determine the hazard locations. Liquids typically do not travel as far as gases unless they're spilled into a path or a channel, such as a storm drain, a river, stream, some type of a waterway. Most departments have something we can cover storm drains with, mats or something, mats and booms. Most of, I know everybody in Dickinson County does, because the emergency manager got it for us, so we know we can cover that to keep liquids from going places we don't want them to. Liquids, they'll flow and pool according to the surface contours, topography, permitting opportunities for containment or confinement. So this is stuff that we need to find out, whether it's heavier or lighter or whatever, and we can start damming up some of these cricks and stuff so it doesn't go so far. We gotta try to contain it. Problem with liquids, we gotta remember they splash. So we gotta make sure that we have the right suits for splash. Gotta remember, some of these liquids, they do have gases that come off from them. So they have gases by emitting vapors, okay? Like gasoline. What burns on gasoline? It's not the gas, it's the vapors, okay? The vapors from liquids prevent additional hazards. That makes the hazardous material mobile. Challenges the first responders. We gotta figure out which way the vapors are gonna go now. They travel a lot like gas. Much more difficult to detect than liquid itself. Be cautious and alert to vapors from liquids. They might be contact hazards, inhalation hazards. They could be flammable, they could be corrosive, they could be toxic. Solids are the least mobile of all three states of matter. They typically remain in place unless we have something acting against them, some exterior force. That could be something like wind, water. We talked a little bit about that Thursday, about a fertilizer shack at the elevators. A lot of them don't want water on them, okay? cause that just makes a bigger mess to clean up, bigger hazardous mess. Yeah, third one in that, we have, wind, water, and gravity. Remember, if it spills up high in a building, it can roll over the edge, gravity will bring it down. Okay, so remember that. A particle size of solids such as dust, fumes, powder, that could influence their behavior. You know, the larger particles will probably settle out of the air, the smaller ones will remain suspended. Solids could have the following dangerous properties: inhalation or contact hazards, small combustible particles, they can ignite, explode. We could get entrapment hazards. It could be flammable, reactive, radioactive, corrosive, toxic. Okay, there's multiple hazards for solids. Usually you can detect a solid by visually seeing it, although sometimes we have microscopic particles. This makes the visibility to detect this present of solids harder. It's easier to see the gases though with the particles in it. Okay, we're getting into some physical properties. These are some of the terms that will probably be the most important that you'll have in hazardous materials. You need to know some of this stuff so you know how some of it acts. We have vapor pressure, boiling point, melting point, vapor density, solubility, specific gravity, persistence, appearance and odor. That's all going to describe how something acts. Vapor pressure, that's the vapor pressure that's present, is the pressure exerted by a saturated vapor above its own liquid. It's in a closed container. It's the pressure produced or exerted on vapors as they're released from the liquid. Usually they're reported as pounds per square inch, kilopascals or bars, millimeters of mercury, atmospheres. Okay, a material that has vapor pressure over 760 millimeters of mercury will be a gas under normal conditions. The higher the temperature of the substance, the higher the vapor pressure will be. Vapor pressure of a material at 100 degrees Fahrenheit will always be higher than vapor pressure of the same material at 68 degrees. Okay? The higher temperature provides more energy to a liquid, which allows more liquid to escape into a gaseous form. Atmospheric pressure is the baseline that we use for measurements for pressure. A boiling point That's the boiling point is the temperature at which a liquid changes to a gas at a given pressure. Usually boiling points are expressed in degrees of Fahrenheit or Celsius. And basically this all starts out at sea level. Flammable materials with low boiling points generally present special fire hazards. Okay, we talked about this last time. When we have a container that's under a lot of heat and stress, and we have that violent rupture, what do we call that? Levy. Boiling liquid expanding vapor explosion. The resulting increase in the internal vapor pressure exceeds the vessel's ability to relieve the excess pressure. The container will fail catastrophically. Okay, remember, they used to tell us the ends of the propane cylinders would come out. Now we found out that it doesn't matter. They can go in all directions. Levies most commonly occur when flames contact the tank. Do they even do that class anymore where you can go up and shut the valve off? I haven't seen it for a long time.
Using the fog pattern?
Yeah, I've done it several. Matter of fact, we did it down here one year, out by, what's the park by the airport? Spear?
Spear Park.
Yeah, we went out there and did it. The training barrel has, I think it was training barrel. They have a propane cylinder, the big one, 500 gallons or whatever, and they got part of it cut out, and they got it full of water, and they bubble propane up through it, and so it goes through the relief valve, and it gets to screaming. You actually get to go up there and reach through the fog pattern and shut the, well, you don't actually reach through, they push the fog pattern, and then you shut the valve off. It shuts the propane off. Pretty intense, but I haven't seen that class for a long time.
There was a picture of it in our firefighter one.
Yeah, it's, we've done it, I've done it, it's a gutsy little deal to go up there and turn that valve off. You know how much water it takes to do that? You got two fog patterns going with you, and the fog patterns to the ground and up and overlap, and you walk up, you get it past, you reach in and you shut the valve off, and they're spraying water over the top of you. It takes a lot of water. And this was contained or controlled. You know, if that's been burning too long, I just say, yeah, it's gonna go pretty soon, let's all stand back. So, just remember, those things can get pretty violent. Melting point, freezing point. Melting point is a temperature at which a solid substance changes into a liquid state at normal atmospheric pressure. Ice cube melts just above 32 degrees, that's its melting point. Freezing point, temperature at which a liquid becomes a solid. Water freezes at 32 degrees, that's its freezing point. There's some substance out there that changed directly from a solid to a gas without going to a liquid. That would be something like dry ice. How many's ever seen dry ice and what it can do? Okay. Mothballs is another one.
They readily sell dry ice at Hy-Vee now.
What's that?
They sell dry ice at Hy-Vee now.
Yeah, they were doing that last summer, I think it was.
my stuff frozen.
It's pretty
Yeah.
cheap.
Yeah. Yeah.
It's good for camping trips.
Just remember, sometimes the temperature changes throughout the day. That's due to the weather pattern, exposure to the sun. That could mean that a material in the beginning of the day as a solid may change to a liquid if heated up enough. When's the last break we had?
Do you need another one?
You've been
Well,
going,
I
about-
need to get through this
you've been
too.
going about 25 minutes.
What's that?
25 minutes is how long.
Oh, that's all we're good?
Yep.
God, it seems like 3 days. Okay, well, we'll keep plugging away, guys. Vapor density. This is an important one, because that's the weight of a given volume of pure vapor or gas compared to the weight equal volume of dry air. So that's gonna tell you whether the gas is gonna float or sink, okay? So if it's less than 1, it's going to rise. If it's greater than 1, it's gonna sink. So that's gonna tell us where we're gonna find some of these gases. Some of the ones that are vapor density less than 1 includes helium, neon, acetylene, and hydrogen. Vapor density less than 1 will rise quickly and spread to a wide geographical area. Most gases have a vapor density greater than 1, they will sink. The problem when they sink, they displace oxygen. As we can see, propane that we use for a heating source is heavier, so we find that where? Down low. So we have a problem if we have a leak in a basement, right? That'll fill the basement up. Okay. They're gonna run along and under floors, in sumps, sewers, manholes, in trenches, and in ditches. That's gonna be like propane, hydrogen sulfide, butane, chlorine, sulfur dioxide, chemicals like that. There again, vapor densities are gonna vary with the temperature of the vapor and the gas. Hot vapors will rise, and they'll sink once they've cooled down. So they'll go up until they cool, and then they'll come back down. Knowing whether the gases are going to rise or sink, we have a problem with topography, weather conditions, what's going to happen when the vapors mix. It gives us a general idea, though, what to expect from that specific gas or vapor. You know, where is it going to stay down low? Is it going to fill in the holes? Is it going to go in the ditch? Or is it going to go up and go away from us? Solubility. Solubility, we want to know what percentage of the material will dissolve in water. Okay? Substance solubility affects whether it mixes with water. Solubility information can be useful in determining spill cleanup methods and extinguishing agents. When a non-water soluble liquid such as a hydrocarbon, what's your hydrocarbons? Gas, diesel fuel, okay, that's your hydrocarbons. That when they combine with water, the two liquids remain separate. When we have a water soluble liquid such as a polar solvent, polar solvents are alcohol, methanol, ketone, methyl ethyl ketone. They combine with water. Okay, so they mix with water. This can affect our respiratory system. Sometimes it can be delayed 12 to 24 hours. We could have difficulty breathing, pulmonary edema. We could be coughing up blood. Immersibility, that's the ability of two liquids to mix together. Immersibility, now that's an example where if we have fuel floating on water, it won't sink, it floats on water, so we'll have fire on top of the water because they won't mix. Specific gravity, there's the ratio of the density of the material to the density of the standard material, usually an equal volume of water. So we're gonna be comparing this chemical to the water. Is it heavier or lighter? Why do we want to know that? Is it gonna float on water or is it gonna sink in water? So if we have to put some booms out, do we have to do something to trap it underneath or catch it over the top? Materials with a specific gravity less than 1 will float on water, and if it's more than 1, they sink in water. Persistence, viscosity, that's the ability for a chemical to remain in the environment. Chemicals that remain in the environment for a long time are more persistent than chemicals that quickly dissipate. Most of the time, those are moved by us walking through it or somebody walking through it. So that's how that chemical gets moved. But viscosity is the measurement, how thick something is. Determines how easy it'll flow. Usually the hotter the liquid, the thinner, the more fluid it becomes. And likewise, the cooler the liquid gets, the thicker, less fluid it becomes. Appearance and odor. Safety data sheets typically contain a description of the material's appearance. Appearance may help you detect the substance or material. You should evaluate a change in appearance. Detecting a chemical by odor, that could indicate the responders are too close. And we got to remember that there is some chemicals out there that have little or no odor, and some don't have any at all. Some have to be odorized so we know what's there. Smell of natural gas is based on the additive mercaptan. And that stuff stinks. Is that in all gas lines, natural gas lines?
No.
No, it's not. So we hit one of the big lines coming in or something, that might not have deodorant in it. They usually add those at substations close to towns. Matter of fact, the one in Spare Lake is not too far from my house, and I can always tell you when they smell a little bit. Cause it comes right across the lake at us. This is a good thing to remember. If you can smell a chemical, you're exposed. Okay? Never use odor to determine. Like we said, sometimes there's nothing there. Responders spending too much time exposed to some compounds may become desensitized. How many times have you guys been in a structure, they say they can smell something burning, you're in there with your turnouts. How long can you smell it?
Couple minutes.
Yeah, not very long. Because why?
You get used to it.
But you get used to it, or you have a little scent on your clothes, you can't smell it anymore. You're smelling the same thing. Even though you try to wash your stuff, you still get some of that on there. But yeah, you do get used to it and you can't smell it anymore. It's better to go out and come back in. Okay, some of the chemical properties. This is gonna be a regular chemistry class. Wow. Chemical properties describe behaviors and interactions that occur at a molecular level. So some of the things we're gonna have at incidents, we're gonna have something flammable, something corrosive, something that's gonna react, something that's radioactive. Your flammable stuff is gonna be any hazardous material involving a flammable material. Flammable materials can damage life, property, when they ignite, burn, or explode. Flammable hazards depend on properties including what its flash point is, what its auto ignition temperature is, and its flammability range. Every chemical has a different flammable length range. Flash point, that's the is the minimum temperature at which a liquid or volatile solid gives off sufficient vapors at its lower explosive limit. And when it does that, that's going to form an ignitable mixture with air. That's the flash point. At its flash point, the material's vapors will flash in the presence of an ignition source. So like the other day when we had the gas leak, we had the cop car running right next to it. So obviously we didn't have enough leaking out of the ground at that point to ignite, but we could have. So we have to watch ignition sources. Don't confuse flash point with fire point. Fire point is a temperature at which a liquid or volatile substance gives off enough vapors to support continuous burning. Okay? Material's fire point is usually only a few degrees higher than its flash point. We talked about this earlier, only the vapors burn, the liquids don't. They just keep producing vapors that will burn. Auto ignition temperature of a substance is a minimum temperature to which the fuel and air must be heated to initiate self-sustained combustion without ignition. So that means that once it's warm enough, it doesn't have to have an ignition source, but once it's warm enough and the fuel load's right, it will start by itself. That's auto ignition. Flammability, explosive, combustible range is the percentage of gas or vapor concentration in the air that will burn or explode if ignited. The LEL, or the lower flammability limit, that's the LFL of a gas or vapor, that's the lowest concentration that will produce a flash of fire when an ignition source is present. So when we're going through with our meters, we're gonna have a lower flammability range and an upper flammability range, so we wanna make sure we stay out of those, okay? Concentration's lower than the LEL, the mixture's too lean to burn. This is just same stuff over and over. This just tells you here again what the upper and lower limits are, what we need to watch for in each one of them. The higher concentration, the mixture is too rich to burn. This is just a chart here that shows you some of the flammability ranges that are particularly dangerous. So look at acetylene there, 2.5 to 100. How's that for a range?
Perfect for cutting stuff.
Yeah, but how often would that be out of range?
Not very often.
Not very often with a range that wide.
Can only have not enough.
You can just crack it, it'll keep burning.
You look at like fuel oil, number one fuel oil, 0.7 to 0.5. Once you're past 0.5, it won't burn anymore. So that's got a low range, okay? Corrosives. Materials that destroy living tissue or destroy, damage or destroy metals. Some of our corrosives, we're gonna measure those with pH paper. We're either gonna have acids or we're gonna have bases. Sometimes we have corrosives such as hydrogen peroxide. That's neither an acid nor a base. Acid is any chemical that ionizes to yield hydrogen ions in water. Okay, acids are going to have a pH value of 0 to 6.9. So that's going to be in your red range there, okay? Acids may cause severe chemical burns to flesh, permanent eye damage. Contact with an acid typically causes immediate pain. Hydrochloric acid, nitric acid, sulfuric acid are examples of common acids. Your bases are going to be water-soluble compounds that chemically dissociate in water, form negatively charged hydroxide ions. The bases are going to have pH values 7.1 to 14. Breaks down fatty skin tissue, can penetrate deeply into the body. Some of those, caustic soda, potassium hydroxide, that's just some of the stuff that's in drain cleaners. Bases can also cause severe eye damage, tissue damage. The bases tend to adhere to the tissue of the eyes. Makes it more difficult to remove. Longer exposures mean that base can often cause more eye damage than acids. Reactivity is a substance described as relative ability to undergo a chemical reaction with itself or other materials. Sometimes when they do that, when they react, we end up with a pressure buildup, temperature increase, formation of toxic or corrosive byproducts. Some of the reactions can be vigorous, some can be violent with the air, water, heat, light. Most of our first responders are familiar with the fire tetrahedron, or the four elements necessary to produce combustion. Remember, we used to have the triangle, now we have the tetrahedron. Used to be oxygen, fuel, and heat. Take away one side, then you kill the fire. Now we have chemical chain reaction, so we have to put something in there to kill the chain reaction. All reactions require some energy to get them started. How much energy is needed depends on the particular reaction. Sometimes heat from an external source provides the energy. We can also use radio waves, radiation, and other waveforms to activate energies in molecules. These are the 9 reactive hazard classes. what this table does is it supplies a definition and chemical examples of 9 reactive hazard classes. Oxidizing agents in the reactive triangle provides the oxygen necessary for the chemical reaction. If you have a strong oxidizer, that's going to encourage a strong reaction. Greater the concentration of oxygen present in the atmosphere, the hotter, the faster, the brighter the fire will be. Many organic materials ignite spontaneously when they come in contact with a strong oxidizer. Okay, what we have here is, what do we refer to this as? Liquid oxygen. What do we refer to that as?
Oxidizer.
Well, when we went through the classes the other day, remember what did we call this? Chirogenic, because
So cold.
it's super cold. Okay, if we get some of this spilled on an asphalt roadway, we have to be real careful, because now with that on the asphalt, it is now shock sensitive. You know what shock sensitive means?
Can crumble.
It'll blow up. So if you ever have liquid oxygen or something like that, any chirogenic spilled on the blacktop, be extremely careful around it. It's got to be on the asphalt. It has something to do with reaction with the asphalt. But it becomes shock sensitive. Reducing agent in a fire tetrahedron acts as the fuel source for the reaction. Whatever it is, it's going to combine with the oxygen, and when you get the oxygen, you're going to get some type of energy release. Oxidation, reduction, redux. Those reactions can be extremely violent and dangerous because they release tremendous amounts of energy. And this just tells about polymerization. Simple molecules form long chains of molecules. The rate increased by catalysts. Examples of catalysts: light, heat, water, acids, some of the other chemicals. Uncontrolled polymerizations often result in tremendous release of energy. Remember when we had that in the book, if it had P behind it, the guide with a P behind it, it would polymerize. Yeah, there they are, right there. So just remember, if you see that P, we got other problems. These increase activate. They needed activation to get energy out. May be exhausted over a period of time, and when exposed to circumstances or unexpected contamination that causes them to consume more rapidly. You see a lot of this stuff going down rail. Styrene, time sensitive. It's been added to the styrene. What they do when they add that to it, we tries to keep it for 20 to 30 days. Cause some days when it's traveling down the rails, it might not get there right away, it might sit in the yard for a while. So they make sure that it doesn't, they put that stuff in so it doesn't polymerize. Under emergency conditions, reactive materials can be extremely destructive and dangerous. Keep people and equipment upwind, uphill, and back a safe distance. Radioactive materials. Radiation comes in different forms. Some of them are more energetic than others. Types of ionizing radiation. We got them divided into four types. Alpha, positively charged alpha particle emitted from a nucleus during radioactive decay, commonly emitted in the radioactive decay. Alpha particles do not travel far in open air, and you may have to get very close to the source of the equipment to detect the particles. Alpha particles, they lose their energy rapidly when traveling through matter, and they don't penetrate very deep. Cause damage over a short path through human tissue. However, they can be very harmful if the material emitting the alpha particles is ingested or inhaled. Alpha particles can be stopped by completely by a sheet of paper, so they're not real harmful, like I said, until you swallow them. Or beta particles, fast-moving, positively charged protons. Humans are exposed to beta particles from manufactured and natural sources such as carbon-14. Beta particles penetrate farther than alpha particles, but cause less damage over an equally traveled distance. Beta emitters are generally more hazardous when inhaled or ingested again. They travel distances in the air but cannot be reduced or stopped by a layer of clothing. Gamma radiation, that has neither a charge or a mass, but they do penetrate. They can easily pass completely through the human body or absorbed in the tissue. Constitute a radiation hazard for the entire body. Materials such as concrete, earth, lead may be useful in shielding against radiation. Standard firefighting stuff does nothing. Neutrons are particles that have a physical mass but no electrical charge. Neutrons are highly penetrating. Fission reaction produces a neutron along with the gamma radiation. Shielding from neutron radiation requires materials with high amounts of hydrogen, such as oil, water, concrete. X-rays and gamma rays. Machines are found in medical facilities. Now we go through them at airports. Some of the machines can only produce X-rays when powered on. Chance of encountering X-rays at a hazardous material incident are remote. Radioactive materials is probably, if we see any of it, it's going to be from a terrorist attack. Radiation exposure occurs when a person near a radiation source is exposed to energy from the source. Damage is often described as terms of dosage. First responder will need to know the type of radiation that will cause damage and what proximity or level of exposure will cause what kind of harm. Radiation does not spread. Radioactive material and contamination spread. Exposure